All right, fourth grade, here we go. We have one more lesson after this one right here. Like I told you, it's crunch time. It's going to be a bit smushed together, so just be sure you're paying attention so you can understand. And it should be pretty straightforward, the last two lessons. So let's get right to it. This is lesson 5.4, factors and multiples. So we've talked about factors of numbers. Factors are numbers that multiply to give you an answer. Or product. So now we're going to talk about what multiples are. So let's look at unlock the problem. Toy animals are sold in sets of 3, 5, 10, and 12. Mason wants to make a display with 3 animals in each row. Which sets could he buy if he wants to display all of the animals? So the product of two numbers is a multiple of each number. Factors and multiples are related. So both 3 and 4 are factors of 12. So they're numbers that multiply by another number to give you 12, okay? Factors of 12. And 12, the bigger number, is a multiple of 3, and it's also a multiple of 4. Because 12 is the answer that you get when you multiply 3 by something. So you ask yourself, is 12 a multiple of 3? You think, do I multiply something by 3 to give me 12? The answer would be yes. Is 12 a multiple of 4? I think to myself, do I multiply something by 4 to give me 12? Yes. Then the answer would be yes, 12 is a multiple of 4. Let's think of another number, just a random one, just to see if we understand. Let's do 7. Is 12 a multiple of 7? Well, can 7 multiply by something to give me 12? No. So 12 is not a multiple of 7. So 12 is not a multiple of 7. What about 6? Can I multiply something by 6 to give me 12? Yes, I can. I can multiply 2. Multiply by 2 by 6 to give me 12. So 12 is a multiple of 6. So you understand, these are factors, numbers that multiply to give, these are factors of the answer, and the answer is a multiple of the factors, okay? Let's look at the blue box. How many animals will be in each row? Well, let's refer back to the problem. Mason wants to make a display with 3 animals in each row. So right here, 3 animals in each row. How many animals are sold in each set? Well, we see here that there are sets sold of 3 animals, 5 animals, 10 animals, and 12. So we're just going to write that. 3, 5, 10, or 12. So let's look at one way. Tell whether 3 is a factor of each number. So we're going to think, is 3 a factor of 3? Can 3 be multiplied by something to give me 3? Yes. 3 times 1. Is 3 a factor of 5? Can I multiply something by 3 to give me 5? No. It's not divisible. Remember we talked about those divisibility rules? Now is when you're going to apply them. Or you can just think like this, multiplying. The next one. Is 3 a factor of 10? Can I multiply something by 3 to give me 10? No. It's not divisible. Is 3 a factor of 12? Can I multiply something by 3 to give me 12? I would say yes. 3 times 4 equals 12. Equals 3 up there. So 3 is a factor of, where did we say yes? That's the two numbers we're going to put here. We see yes at 3 and we see yes at, we see yes at 3 and we see yes at 12. So 3 is a factor of 3 and of 12. Let's look at another way. Find the multiples. So to find multiples, it says you can multiply. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. Or you could have just sang our little song, 3, 6, 9, 12, 15, dot, dot, dot. So now we are going to see which numbers are in common with the numbers presented here, because we can only choose the ones that are similar to these, otherwise it won't fit. So we have 3 and 3, so we know 3 is 1. 6, there's no 6, we have 5, but there's no 5 here. What about 9? No, we have 10, but not quite. 12, we have 12, so that's another one. And 15, there's no 15. So we found the two that are in common. So these right here, these three numbers are multiples of 3, meaning that these are products of 3 that these numbers have in common with. So Mason could buy sets of 3 and 12. Let's move on. Common multiples. A common multiple is a multiple of 2 or more numbers. So this is similar to what we just talked about. Here we're going to find the common multiples. Tony works every 3 days and Amanda works every 5 days. If Tony works June 3rd and Amanda works June 5th, on what days in June will they work together? Circle multiples of 3. Draw a box around multiples of 5. So first let's circle multiples of 3 and draw a box around multiples of 5. So circle. Let's think of multiples of 3, meaning that when we sing the 3 song, it's in there, okay? So let's see. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, almost done. In this case, we are done because there's no more days. Now let's go by 5s. Multiples of 5 means we count by 5s. So products of 5, basically. So we see 5, we see 10, we see 15, we see 20, we see 25, and we see 30. So now this little box tells us right here, think. The common multiples have both circle and a box. So just like yesterday we talked about common factors, we're talking about common multiples. Multiples that the two numbers have in common, what they share similarities with. So that means that we're looking for the ones that have both a box and a circle, because that means that both 3 and 5 are multiples of those numbers. Or, yeah, those are multiples of both 3 and 5. So the common multiples are, let's see, where do we see a box and a square? Oh, here we go. Let's see, where do we see a circle and a square? Oh, here's our first one, circle and square. So here's 15. Let's keep going. There it's the other one, circle and a square, and so we write 30. So Tony and Amanda will work together on June 15th and on June 30th because the common multiples were 15 and 30. That's what they had in common. And these are both multiples of both 15, of both 5 and 3. Okay, so multiples, when you think of multiples, think of like the products, basically. If you're thinking in multiplication ways, multiples are basically products, okay? Products that you get for counting by that number, by whatever number that is. So in this case, we talked about 3 and 5. But in this case, we talked about multiples of 3, okay? That's what we counted by 3. So let's go ahead and do share and show. These 9 questions of share and show, and then it'll be your turn. Multiply to list the next 5 multiples of 4. So you see we're counting by 4s to find the multiples, which are the products. So here we're doing 1 times 4 gives us 4, so let's do the next one. 2 times 4, which gives us 8. 3 times 4, which gives us 12. 5 times 4, which gives us 20. 6 times 4, which gives us 24, and 7 times 4, which gives us 28. Awesome. So right here are the multiples of 4. Awesome. Here we go. Next one. Is the number a factor of 6? Right? Yes or no? So we're going to ask ourselves, is this a factor of 6? Meaning, can this be multiplied by another factor to give us 6? The answer is yes. If we make that 3 times 2, that means it is a factor of 6. What about 6? Is 6 a factor of 6? You should have said yes. What do we multiply by 6 to give us 6? 1. Is 16 a factor of 6? Can we multiply something by 16 to give us 6? The answer is no. What about 18? Is 18 a factor of 6? Can we multiply something by 18 to give us 6? The answer again is no. Cool, easy, right? Next one, is the number a multiple of 6? So now we have to switch the way we're thinking. Is this the answer? Is this a product of when you multiply something by 6? Okay? So multiple, think of product, like I wrote up here, remember? Multiples, think of product. So is this the answer to something multiplied by 6? No. Is this the answer when you multiply something by 6? Yes. What is it? 6 equals what times 6? 1 times 6, right? Awesome. What about 16? Again, the answer is no. 16 is not the answer when you multiply something by 6. So that is a no-go. And 18, is this a multiple of 6? The answer is yes, because if you multiply something by 6, it gives you 18. What is that? 6 times 3. Awesome. Okay, so that's basically it. That's your lesson. All you need to do, excuse me, is think about multiples are related to products and factors are exactly what they are. Factors. You've learned about factors before. So now it's time to go over what your assignment is. Your assignment is to do on your own, which is this page right here, numbers 10 through 21, which is basically what we just did on share and show, okay? The same thing, and the examples of the problem. See, it's the very same thing. Okay, so your assignment is to do on your own, and your assignment is to do the practice as well, extra practice, which again, it's not due until Friday, and I know it's a little bit crunch time. Usually you do have a whole day to do it, but since this is short, and again, we're trying to finish so you can do your test, I want you guys to have a lot of practice, so your assignment is to do both on your own and extra practice, okay? So go ahead on OneNote and work on these things, okay?